Hello students, welcome to Kumar@Students Can Do. Today I am going to tell you a very easy and important problem for SSC examination. In this video I am going to prove that root 2 is irrational. So before going into the proof, let me remind you the definition of rational number. So any number which can be written in the form of p by q, where p and q are integers and the denominator q is not equal to 0 and p and q are co-primes, is called a rational number. So now going into the proof, we have to prove that root 2 is irrational. So we prove this in an indirect method, that is, you assume root 2 is a rational number. Assume that root 2 is a rational number. Then by definition of rational number, root 2 can be written in the form of p by q, where p comma q are integers, they are co-primes, and the denominator q is not equal to 0. Again, what do you mean by p comma q are co-primes? That means the greatest common divisor for p and q is 1. The greatest common divisor, that is GCD for p comma q is equal to 1. Keep it in mind, we are going to prove converse for this assumption. We are going to bring contradiction to this assumption. Okay. Now we have root 2 is equal to p by q. Now we are bringing this p to LHS. Then it becomes root 2 into q is equal to p. Next you do squaring on both sides. That is root 2 into q whole square is equal to p square. Now this is in the form of ab whole power m. So this can be written as a power m into b power m. So from the formula, assume that this is a and this is b. So root 2 whole square into q square is equal to p square. Here square and root gets cancelled. So 2 into q square is equal to p square. Take this as equation 1. From this equation, p square is a multiple of 2. P square is a multiple of 2. That means 2 divides p square. If 2 divides p square, then 2 divides p. So 2 divides p. Then again from the definition, if 2 divides p, then p can be written as a multiple of 2. That is, p is equal to 2 into some integer k, where k is an integer. Now substitute this p value in equation 1. So substitute p is equal to 2k in equation 1. So 2 into q square is equal to, in place of p you keep 2k whole square. Again this is in the form of ab whole power m. So this can be written as a power m into b power m. Here 2 and this square gets cancelled. That is, q square is equal to 2 into k square. So again you got q square is a multiple of 2. That means again 2 divides q square. Same following the above logic, if 2 divides q square, then 2 divides q. Take this as some star and take this as some hash. So from star and hash, see 2 divides p and 2 divides q. That means 2 divides both P and Q. That means 2 is common divisor for P and Q. This is not possible. Why? Because P comma Q are co-primes and the greatest common divisor for P comma Q is 1. But here you got 2 divides both P and Q. This is a contradiction. This is a contradiction to our assumption that P comma Q are co-primes. Why we got this contradiction? Because of a wrong supposition that root 2 is a rational number. Therefore, our supposition is wrong. So, our supposition that root 2 is rational number is wrong. Therefore, root 2 is an irrational number. My dear students, if you learn this one problem, you can solve all the problems in this model. Suppose if they ask you to prove some root 3, root 5, root 7, root 11, root 13, all these numbers are irrationals, then simply in place of 2, you substitute 3. If they asked you to prove root 5, then in place of 2, you simply substitute 5. So, if you learn this simple problem, 8 marks question, then you can solve any problem related to this type. Hope you understood the problem and I hope you to secure the total 8 marks without missing any step. Thanks for watching. If you like it, please like and subscribe. Thanks for watching. Bye bye. Take care.